Using the parent function f of x graph below, we want to graph g of x using the new function rule g of x equals 2 times f of the quantity x minus 1 minus 3. We may recognize f of x as f of x equals x squared. And if we do, notice this indicates f of the quantity x minus 1 equals the square of x minus 1. And we could write g of x as g of x equals negative 2 times the square of x minus 1 minus 3. And notice this is the vertex form of a quadratic function where h comma k is the vertex. So the vertex is 1 comma negative 3. And then from there we could find additional points. But that's not really the point of this question. The point of this question is to practice function transformations, which is the approach we will take. Recall if g of x is a transformation of f of x, we can write g of x as the form shown here. Notice for our function rule g of x, we have a equals 2, b the coefficient of x is 1, c is positive 1, and d is negative 3. Recall a equals positive 2 indicates a vertical stretch by a factor of 2. B equals 1 indicates there is no horizontal stretch or compression, and therefore b does not affect the transformation. C equals positive 1, which indicates a horizontal shift of right 1 unit, and d equals negative 3 indicates a vertical shift down 3 units. Before we perform the transformation, let's find 3 key points on the graph of f of x. We'll use the vertex, which is 0, 0. And let's go ahead and use, let's say, 2, 4, as well as negative 2, 4. And now to perform the transformation, we'll work our way from inside out, starting with the x minus 1, which indicates c equals 1. Again, this means the graph is shifted right 1 unit. This affects the x coordinates, or the x values. We will now add 1 to each of the x values for the 3 ordered pairs that we selected. Starting with the origin, adding 1 to x, the new vertex is 1, 0. For the point on the left, negative 2 plus 1 is negative 1, giving us negative 1, 4. And for the point on the right, 2 plus 1 is 3, giving us 3, 4. And now we graph the parabola. This is the parabola shifted right 1 unit because c equals positive 1. Again, working our way from inside out, next we have a equals 2. This indicates a vertical stretch by a factor of 2. This affects the y values. So now we'll take the 3 key points on this graph and multiply the y values by 2. For the vertex, 0 times 2 is still 0. The vertex is still 1, 0. For the points negative 1, 4 and 3, 4, 4 times 2 is 8. We have negative 1, 8 and 3, 8. Let's go ahead and graph the parabola. This is the parabola after being shifted right 1 unit and vertically stretched by a factor of 2. And then finally, because of the minus 3 on the end, we know d equals negative 3. This indicates a vertical shift down 3 units. We now subtract 3 from each of the y values of the 3 key points. For the vertex, 0 minus 3 is negative 3. The vertex is now 1, negative 3. And then for the 2 remaining points, 8 minus 3 is 5, giving us the point negative 1, 5, and 3, 5. This is the graph of g of x. I hope you found this helpful.